All right, now we're going to work on ions. We're going to learn how to draw Lewis dot structures or Lewis structures for ions. All right, everything we've drawn so far has been a compound, neutral. Ions, as you remember, can have a positive or a negative charge on it. The ones we're going to draw here are anions, so we're going to use ones with negative charges on them. But there's really nothing different here. I should say nothing different in that we're going to follow all our steps. We've got to make one variation when we do the available account, because the minus sign or the plus sign means that we've got to adjust our available number accordingly. For every minus sign, we're going to have to add that many electrons to the electrons available for bonding. And if it's a positive, or for every positive sign, we've got to subtract that many electrons from our available count to be involved in the bonding. And one final thing that we have to do for ions is we have to put them in a set of brackets and put the charge outside that bracket so we know, so we can communicate to each other that we are drawing the structure of an ion and not a neutral compound. So, again, let's walk through your steps. If you want to, go ahead and put this on pause and do what you can for ClO3-, the chlorate anion, and we'll see what you come up with. In the meantime, I'm going to go ahead and talk through this, but like I said, if you're feeling pretty confident right now because you've been able to do all these others pretty well, put this on hold and give it a shot and then come back and check it out. All right, if I'm going to draw this structure, I'm going to do my NASB method. No hydrogens, so I see 1 chlorine and 3 oxygens, so I see 4 atoms, each of which needs 8 electrons to make this work, for everybody to have 8. So that would be 32 needed. All right. Available, we're going to do this like normal to start with. I've got 1 chlorine sitting in group 7, so it's going to bring it 7 electrons. And I have 3 oxygens, each sitting in group 6, so they're going to bring their 6 valence electrons. All right, and if I do my addition at this point, I get 3 times 6 is 18, and 7 is 25. And we said that's already a problem. But I want you to look. We've got this electron right here. We've got a minus sign on it, which means that this formula I see has 1 extra electron in it, and so I'm going to adjust right here. I'm going to add that there, and so I really have 26 electrons that I have to end up assigning when I get done here. All right. So if this would have been a minus 2, I'd had to add 2. If it had been a minus 3, I'd had to add 3. If it had been a plus 1, I'd had to subtract an electron. So you have to make your adjustment right here in the available. All right. Shared, 32 minus 26 says we've got to share 6 electrons. Bonding says 6 shared electrons divided by 2 electrons per bond says I have to have 3 bonds in this compound. My central atom is going to be chlorine. Now, I know we've said in the past that the halogens do not like to be in the center. And the caveat was unless they have to be. And if you look at this compound, I have 3 oxygens and 1 chlorine. So we would put the chlorine in the center of this compound. All right. So we're going to come over and do that. We're going to put our chlorine in the center. We're going to put our 3 oxygens around it in some kind of symmetrical pattern. And then I'm going to draw a single bond to each one. I have put in 3 bonds. I needed to put in 3 bonds, so that's good. I've done that. That's taken care of. Now I have to go assign my 26 electrons, starting with the outside elements and giving them what they need. This oxygen already has 2, so I'm going to give this one 6 more. This oxygen has 2, so it needs 6 more. This oxygen has 2, so it needs 6 more. All right, so my 3 outside elements, my 3 oxygens, each have 8 electrons. So I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, but I've got to use 26. All right, so what was our rule? If if I have extra available electrons that haven't been assigned after I've taken care of all of my external elements, I have to put them on the central atom in pairs. All right, so there's my pair on there. Now, everybody has 8. Each oxygen has 8, and chlorine has 2 in that bond, 2 in that bond, 2 in that bond, and 2 in that unbonded pair, so it has 8. And so we said the last thing I need to do for an ion then is to make sure you know it's an ion and that I know it's an ion. So I'm going to put the structure inside a set of brackets, and I'm going to put this negative sign right there. I'm going to just draw it up there. That tells me we've got an ion here. Excellent. Okay. Everybody can do that. If you think about it, we didn't really do, we made 2 changes to what we normally do. We had to adjust our available count to reflect the charge. We have to adjust to reflect the charge. All right. And we had to put a set of brackets around our final compound with the charge on it to make sure that you and I both know that that is an ion and not a neutral compound. Okay. What I want you to do then is to practice, and I want you to practice with ICl4, and it's going to have a minus charge on it. Okay? ICl4, and it has a minus charge on it. So go ahead and practice that, and let's see what happens. Put this on pause, go through your steps, draw your compound correctly, and let's see what you come up with. Okay, if you're back, hopefully you have successfully drawn the ICl4 minus ion. All right? No hydrogen, so you did your N, 5 atoms, 1 iodine and 4 chlorines, times 8, so you need 40 electrons. You did your available. You had 1 iodine sitting in group 7 and fluorochlorine sitting in group 7. When you did that math, you got 28 and 7 is 35. You had your minus charge up there, so it means you had 1 extra electron to add to your available count, which gave you 36. 40 minus 36 said 4 electrons had to be shared. Your bonds had to be 4 divided by 2, or 2 bonds. All right, choosing the central atom should have been pretty easy. Iodine and chlorine are both halogens. Iodine is less electronegative than chlorine, and it's the only one of its kind, so it's going to be the central atom. You went over and drew your central atom right here. You put your 4 chlorines around it in a symmetrical pattern, and you put a single bond in to each one. You had used 4 bonds. This thing said you had to have 2 bonds, so you know you've accounted for those, and there are no multiple bonds in there. So now it's time to go back and assign your 36 electrons, starting on the outside elements first. Each of the chlorines already had 2, so you gave each one of them 6 more. That then, you did your count. So you had used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So you'd used 32 electrons, so it said you had 4 electrons you had to put somewhere. And our rule is they have to go on the central atom. They have to go on in pairs. So I put a pair in that space, and I put a pair in that space so that we can both see them. All right. So now each of the chlorines has 8, and the iodine has 12, but that's okay. Iodine is way down in the periodic table, so we know it has s and p and d orbitals, so it can handle those extra electrons. All right, so we've assigned the right bonds, we've assigned all 36 electrons, but again, since it's an ion, we're going to put the brackets around it, and we're going to put the charge out there outside the brackets. That, ladies and gentlemen, is an excellent Lewis dot representation of an ion. Don't forget on ions to put the bracket and put the charge out there. Everything else pretty much the same. Just adjust your available account to account for the extra minuses or the loss of electrons with the positive charges. So that pretty much ends our little segments on how to draw Lewis dot structures. You will be asked to do that in upcoming homework assignments, quizzes, and probably on the exam that goes with this unit. So, practice makes perfect, so keep at it. That's going to end this video.